Hello, my name is Nick Grue, and I'm with the National Renewable Energy Laboratory, and this is the second video on our tutorial of technical potential analysis. This video will focus on assessing technical potential. To review, there are multiple kinds of potentials, including resource, technical, economic, and market potential. But we are focusing on resource and technical potential. When selecting exclusions, you need to ensure you have a wide variety of exclusion datasets available to properly capture technical limitations for the kind of energy technology you are considering. There are many different types of barriers to new developments, including environmental, land use and land cover, public acceptance, infrastructure, and resiliency and risk. Environmental barriers may include protected areas like national parks, sensitive wildlife habitats, and terrain. Land use and land cover considerations may include agricultural lands that would be lost due to solar park developments but may be generally unaffected from wind turbine development. Public acceptance has to do with the public having favorable or unfavorable opinions about new solar or wind projects. Infrastructure considerations can include proximity to airports and radar stations, which would inhibit wind turbine development but may not affect solar park development. Resiliency and risk considerations may include avoiding development in floodplains or areas prone to landslide, and also to ensure no threat to food and water security. How do we define a spatial barrier or exclusion? Spatial exclusions or barriers are potential restrictions to the development of an electric generator on a parcel of land. Some exclusions blur the lines between technical potential and economic potentials, for example, slope and proximity to roads or transmission. It may be technically possible to develop solar parks on high slope or far away from transmission lines, but there will be additional costs to developing in these places in terms of investment into new infrastructure. Inclusion layers can also be included in this analysis to ensure development in more favorable areas. For example, development of new projects within a certain distance of a coal mine. How should exclusions be determined? Experts can help define areas that are viable or non-viable for new development. Stakeholders are also invaluable for determining exclusions because they likely have the greatest knowledge on land uses. For example, stakeholders would likely have better knowledge of the multiple ways a piece of land is utilized by the community, which a satellite image of land wouldn't be able to characterize. Exclusions can significantly change the technical potential, so using accurate data with input from key stakeholders is crucial. Exclusions will fundamentally alter the technical potential as well as additional analysis further downstream. When developing exclusions for downstream analysis, it is advisable to consider multiple exclusion scenarios. Scenarios will allow for the relative comparison and evaluation of exclusions on technical potential. Unique exclusions should be developed depending on the technology you are considering. For example, wind turbines generally are more difficult to develop near large population centers, while community solar parks are more acceptable. Solar parks may be more restricted in building on agricultural lands, while wind may have less of an impact on these lands. Now let's take a look at example analysis to see how exclusions will change technical potential. Here we see multiple scenarios of the same location with different exclusions applied. We have the nameplate capacity, total land area, and DC generation, which are generally the outputs of technical potential analysis. The first scenario is the baseline where we don't have any exclusions. The second scenario is a minimal exclusion scenario where we are only excluding out protected areas. Here, between the baseline and the minimal exclusions, we can see that the nameplate capacity, total land area, and DC generation are reduced as we consider better areas for development. In the moderate exclusion scenario, we're excluding protected areas and croplands. As we become more restrictive in this high exclusion scenario, we're excluding protected areas, croplands, and any areas with slope greater than 5%. And here you see the nameplate capacity, total land area, and DC generation is still further reduced as we're zeroing in on the best places for new development. And in the most strict exclusion scenario, we're excluding protected areas, croplands, slope greater than 5%, and any areas that are further from a road than 5 kilometers. Here, showing the difference between the baseline scenario and the strict exclusion scenario, you can see the kinds of difference that will be experienced depending on the types of exclusions you are considering. Check out the other tutorials in the series on technical potential analysis, including using the technical potential tool in RA Explorer and the introduction to technical potential analysis. Thank you.